A well-aligned model gives you a useful baseline, but it is not the safety layer protecting your production agent. I'm Merdad, and today we'll separate model alignment from the runtime guardrails your team can actually inspect and control. Then we'll build those controls around the complete agent loop, covering requests, conversations, tool calls, outputs, and permissions. Saying the model is aligned does not create a safety plan for the policies and risks inside your application. Alignment is trained into opaque weights using broad goals and general examples, rather than rules your team can inspect directly. When requirements change, you cannot edit one policy in those weights or audit exactly how the model will enforce it. The model also cannot know every forbidden topic, protected field, data boundary, or approval requirement unique to your operation. Your application still needs controls you can configure, test, audit, and update without retraining anything. Real safety is a runtime layer your system executes around the agent before and after important decisions. These guardrails remain programmable, auditable, and independent of whichever underlying model currently supplies the intelligence. They encode your specific data boundaries, approval gates, forbidden actions, and escalation rules where the application can enforce them. You can replace the model while preserving the same controls, or tighten one policy without retraining the system. Safety becomes an operated component you can inspect and swap, rather than a hope hidden somewhere inside the weights. Put alignment and guardrails side by side because they solve related problems at very different layers. Alignment is baked into the model for broad behavior, making it difficult to inspect and impossible to swap independently. Guardrails are bolted around the agent at runtime, where your team can write, test, and enforce them on every call. Those rails can remain stable even when the model underneath changes, which keeps application policy under your control. This is not an either-or choice. Alignment provides the baseline, while runtime rails complement it with explicit rules. A complete design places checks at 4 boundaries around the loop, because no single filter can observe every risk. Input rails screen requests before the main model receives them, catching injection attempts, jailbreaks, and sensitive incoming data. Dialog rails keep the evolving conversation inside approved topics, workflows, and transitions as the interaction unfolds. Execution rails validate proposed actions and their parameters before any external tool actually runs. Output rails inspect the final response before users or downstream systems receive something unsafe. Together, these 4 rails wrap every turn before, during, before acting, and after, rather than filtering only the final text. Strong input and output rails often use a separate, purpose-built safety model instead of asking the worker to police itself. This smaller classifier has one focused job: identify unsafe content before it enters or leaves the main agent loop. Because it follows a different reasoning path, a jailbreak that fools the worker must still bypass a guard trained specifically for detection. Separation also makes operations cleaner because you can measure the guard independently, adjust thresholds, and replace it at relatively low cost. You can update policy categories without disturbing the model doing the actual work, giving safety its own auditable evaluation surface. Many safety systems inspect only the text entering and leaving the model, which misses the most dangerous moment in an agentic workflow. The real risk often lives inside a structured tool call such as a delete command, payment request, or file path outside its sandbox. A content filter may approve the surrounding prose without ever examining the arguments that determine what actually happens. Execution rails must validate the complete call before dispatch, including the tool name, parameters, target resource, amount, and required approval. Reject path traversal, destructive operations, and unauthorized destinations directly at that boundary before side effects become irreversible. The decision to act deserves stronger controls than the words surrounding it. Guardrails can catch bad actions, but least privilege removes many dangerous possibilities before a runtime check becomes necessary. Give each agent only the tools and permissions its role requires, rather than handing every worker the orchestrator's complete toolbox. In multi-agent systems, delegation should narrow authority as work moves downstream, because a child task rarely needs every parent capability. A research agent might read approved sources without gaining permission to send messages, change records, or invoke payment tools. Smaller authority creates a smaller blast radius, fewer checks to maintain, and less damage when another control eventually fails. Here is the through line. Safety is a layer you run, not a property you assume the model already has. The model supplies capability and proposes decisions, while the harness supplies rails, guard models, approvals, and constrained permissions. Those operated components turn general intelligence into controlled production behavior by enforcing explicit boundaries around every consequential step. Trustworthy operation does not come from confidence that the model will always choose correctly when the cost of failure matters. Carry these 3 takeaways into your next agent design. First, alignment provides a baseline, while application safety requires explicit runtime guardrails your team can inspect and control. Second, protect input, dialog, execution, and output boundaries with appropriate checks, including a separate guard model and tool call validation. Third, apply least privilege before adding more filters by narrowing every agent's tools, permissions, and delegated authority. Run the rails instead of merely trusting the weights, and make every important boundary something your team can inspect. If this series is useful, subscribe to Multi-Agent Academy, and you can also connect with me on LinkedIn. Next is video 14, Observability and Failure Attribution, where logging every step still won't tell you which one broke the run. I'll see you there.